All right, next on our agenda is solution stoichiometry, which is just one more type of stoichiometry problem. All of the rest of the rules and tricks that we've learned in our stoichiometry problems will still hold true. We're just adding one more trick to our bag. So what's going to happen in solution stoichiometry is the use of molarity. And so you need to keep in mind that molarity of a solution is just the ratio of the moles per liter. And so when you're doing your problems, remember, molarity is moles over liters. I suggest, though, when you get that capital M, that you rewrite it out as the MOL over liters. So, for example, if it says it's a 6 molar solution, I would rewrite that as 6 moles per 1 liter. And think of it, though, as standing as 6 moles equals 1 liter. It's very similar to molar mass. How in molar mass, for example, for water, you know, like 18.02 grams equals 1 mole. If we have 6 molar solution, we know 6 moles equals 1 liter. The only thing that's different about solution stoichiometry than what we've dealt with before is we used to always have 1 mole equals another number, and now we have a number by the unit of moles. So keep that in mind. So this measurement of molarity can be used for stoichiometry to set it up so that the units cancel, which is the general rule for dimensional analysis. Some things to keep in mind also: make sure that all of your units for volume are in liters. So if you have milliliters, you got to get rid of those. If you have grams, remember grams are going to have to be converted to moles so that your moles will cancel with the moles in molarity. So here we go. Let's do some sample problems and dig in. Oh, and by the way, because it is stoichiometry, that means you must have a balanced equation. Why? Because stoichiometry means we need a balanced equation because we need the mole ratio. All right, so back to what I was saying. Sample problems. How many grams of solid calcium hydroxide are required to react with 350 milliliters of 0.40 molar HCl? So remember, when we're describing a solution, molarity gets replaced by the word molar. So molarity is when we're saying the word as a noun, but when we're describing something, we use the word molar, like the molars, like your teeth. All right, so I know this is stoichiometry. How do I know it's stoichiometry? Because they talk about one thing and then they talk about another thing. So to speed things up here, I went ahead and gave you the balanced equation. You might not always be given the balanced equation, but here I did. So they're asking for calcium hydroxide. And we also know we have 350 milliliters of 0.40 molar HCl. So I know I have 0.350 liters. Where did I get that? From the 350 milliliters. I went ahead and moved my decimal 3 to the left. Remember, milliliters have to go bye-bye because we cannot use milliliters. Got to use liters. And then 0.40 molarity, and I'm going to change that to 0.40 moles over liters. All right, so I always tell my students, and we're looking for grams, like I said, rarely are you ever going to start off your stoichiometry with molarity. So that means what's left? Well, what's left is this right here. So we're going to start off with our liters, 0.350 0.50 liters of HCl. Dimensional analysis says that needs to go on the bottom. What do we know about HCl's liters? Well, for every 1 liter of HCl, they've told us we have 0.40 moles of HCl. Why? Because that's our molarity, 0.40 moles per liter. Liters cancel. What do we know about moles of HCl? Well, we know according to our mole ratio, for every 2 moles of HCl, we're going to need 1 mole of calcium hydroxide. Now, calcium hydroxide, well, now we're into what we want, and we want to go to grams. Well, moles need to go on the bottom. And we want to go to grams. Well, how do we go to grams? We go to moles. Or from moles to grams, we use not molarity, but you guessed it, molar mass. Calcium is 40.08. 2 oxygens are 32.00, and 2 hydrogens are 2.02. So when you add all of those up, you get 74.10 grams, and again, that's in 1 mole of these. Moles cancel, multiply and divide, and oh, I was bad over here with my sig figs. I put 0.350 and it should have been 0.35. There was no terminal decimal after that 0 in 350 milliliters. I should not have put it over here. All right, so finally with 2 sig figs, my final answer is 5.2 grams of calcium hydroxide. Final answer. All right, next one. We have sodium iodide, and we have 0.075 liters of 0.20 moles per liter. And they want to know how many milliliters of 0.10 moles per liter. All right, so just like before, we're going to start off with, I'm going to use red. We're going to start off without using molarity to start, so that means we're going to start with what I call my single unit, not a fractional unit. So 0.075 liters of NaI. Again, why did I choose that? Because the other one is my, this one here is a fraction because it's got a numerator and a denominator. All right, so I have liters of NaI on the top, so I need liters of NaI on the bottom. What do I know about them? For every 1 liter, I'm going to have 0.20 moles. That's the molarity. So if you look at it, I've used both of these numbers, so those have gone away. I have moles. Once you have moles, you're ready for your mole ratio. According to this, moles of NaI are going to go on the bottom. I have 2 moles of NaI for every 1 mole of lead 2 nitrate. Now, unlike the previous sample problem, they don't want the mass of that substance. They want the milliliters. So moles of lead 2 nitrate need to go on the bottom. So here's what you got to follow. What do I know about the moles? I know that there's 0.10 moles in a liter. So all I did was take and flip. I flipped that molarity. Just like we flip our molar masses when we put them on one side or the other side. And when I get this, I get 0.075 liters of lead 2 nitrate. But be very thorough because I'm not done with the answer, because the answer asks for how many milliliters. So to go back to milliliters, I have to move my decimal 3 places back over, and then I need 2 sig figs. So my answer here, my final answer is 75 milliliters of lead 2 nitrate. And that is your final answer. So with solution stoichiometry, units are what are going to help you. Remember, if it's with mass, you're using molar mass. If it's with molarity or solutions, you're using molarity. If it's with the volume of a gas at STP, you're using 22.4 liters are in 1 mole. If it's particles, you're using Avogadro's number. So you're just adding one more thing to your bag of tricks.